Hello, welcome to another episode of Physics with Chris. In today's lesson, we are looking at Newton's equations of motion. Newton's equations of motion. And these are Newton's equations of motion, where all the parameters have their usual meaning. The V is final velocity, U is initial velocity, A is acceleration, and T is time. You have V final velocity, U initial velocity, A acceleration, T time, then X is distance. So those are the parameters. Now, how do you apply these equations of motion? Because in questions they are not going to tell you which of the equations of motion to use, but from the question you can easily know which of the equations to use. How do you know that? By the time you have written the parameters out, look at the equations of motion. Which of the equations contains everything that you are given and what you are looking for? Like that, it will enable you to know which of the equations of motion to use. Now, take for example, let's look at this question. A car moving with a velocity of 15 meters per second, accelerated uniformly at the rate of 2 meters per second squared. Calculate the distance traveled when the velocity reaches 20 meters per second. A car traveling with a velocity of 15 meters per second, that's initial velocity, traveling with. Then if our initial velocity U is 15 meters per second, accelerate uniformly at the rate of 2 meters per square seconds. Acceleration now, A, is 2 meters per square seconds. Acceleration A is 2 meters per square seconds. Calculate the distance traveled, that's X, is equals to when the velocity reaches 20 meters per second, that's final velocity, is now 20 meters per second. Now, since I've written the parameters out, I will look at these equations of motion. Which of the equations of motion contains all these parameters and what I'm looking for simultaneously? The equation of motion that you are going to apply must contain all these parameters and what you are looking for simultaneously. Then if you look at the equations of motion, these four, then look at these parameters. Which of them contains what I'm looking for and all the other parameters? If you look at them carefully, let me give you 2 seconds so that I can look at the equations of motion and the parameters. I was hoping that you would say is equation 3, because equation 1 contains time and there's no time here. Equation 2 also contains time, though it has distance that I'm looking for, but because it has time and there's no time in the parameter, I cannot use equation 2. So I'm going to use equation 3. Now, applying equation 3, using equation 3 now, which is V squared is equal to U squared plus 2AX. Then you have 20 squared is equal to 15 squared plus 2 times 2 acceleration now times X distance. 20 squared, that will give me 400. 15 squared, 225 plus 4x. Collect like terms now. I will have 400 minus 225 is equal to 4x. Then you have 400 minus 225. Now give me 175 is equal to 4x. I'm looking for x. I will divide both sides now by 4. Then my x will be 175 divided by 4. So my x should be equal to 43.75 meters. So this is one way that you apply Newton's equations of motion using this example. And look at the way the solutions is neatly set out. So for more examples on equations of motion, please subscribe to this our YouTube channel, Physics with Chris, because more examples are still coming. And turn on the notification so that you can be the first to see our videos immediately we drop them. Thank you.